whatever. Chanel.
31 from 6.2.
Before your arm goes out of socket, you know.
Oh, what?
I said before your arm goes out of socket. I was just teasing you.
No, it's fine. It's fine. I was way too eager. Sorry, we just had a bio test move, so we're just all like.
I'm a good mood.
You know what? I'll take it. If everybody,
Did it make sense?
Did I ask you?
if we can just kind of be like all engaged and excited to be here, that sounds good to me. All right, here we go.
There you go.
You whoop yay calc. All right, 31, correct?
Yes.
It says set up an integral for the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. Then use your calculator to evaluate blah, 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 blah. Okay. So let's start by graphing this thing. So we have y equals 0, x equals -1, and then x equals +1. And then it's about the x-axis. All right, well, that's fine. All right, so let's plot e to the -x squared. So if I plot this, I would probably plug in -1, 0, and +1, and just get an idea of what the thing is going to look like. When I plug -1 in, I get 1 over e. Everybody's okay with that? 1 over e is like 1 over 2.7, so it's like a third-ish. You know, so like whatever. And I get the same thing for +1. If I plug in 0, I get 1, right? So it's probably going to look like something like that. It's okay. I'm just kind of guesstimating it. It doesn't matter super duper much. As long as I have a good idea of like whether there's a hole or not in there. Everybody's good? Chanel, you okay?
Yeah, so did you just plug in the -1 and the 1? Is that all you did?
And 0.
And 0? So why do you have to plug in the 0?
Just to give me an idea of like, I guess it doesn't really matter, but it would definitely matter if it was like down here, because now it's going to be a convex thing as opposed to, or a concave thing as opposed to convex.
So is it just to help like imagine the rotation?
I basically want to check to see if it's concave or convex, because if it's concave, I'm going to do one thing. If it's convex, I would do another.
Is it pretty, so I just like, this is just a general question, but are you pretty much plugging in the intersection points? Like if there's two curves, let's say there wasn't any boundary, but there were two curves, you are plugging in like the intersection.
Yeah, I'd want to know where they intersected, but I'd also want to know like, it kind of depends. I kind of want a decent picture of it. I don't have to have like the bestest ever picture of it, but like pretty good pictures, you know, happy. Are you okay with how I got to this picture?
Yes.
Okay. So if I'm rotating around this, I'm going to end up with a convex object, right? It's going to be like a cylinder that gets fat in the middle. Everybody okay with that?
Yeah.
I mean, it's on its side, so it's like... Everybody's okay? Chanel, you're okay?
Yeah.
All right. So if it's convex, I'm sorry, yeah, if it's a convex solid, I am using washers. Every time.
It's easy to get the circle out of the
Yep.
image.
Yep. Because just, that's the radius, right? What's that radius the same as? Try again. Y.
Which is the function.
Which is this. So my cross-sectional area is pi r squared. So that's pi e to the -x squared, right? What do I get when I do that? Right? Exponent of an exponent we multiply.
But why would it be negative 2x squared, not negative x to the fourth?
So if I have e to the negative x squared times e to the negative x squared, that's e to the negative x squared plus negative x squared. Right?
That's why I messed up. Keep on going.
So that's just like exponent rules. Oh no, those things matter? Of course they do. So our volume is going to be pi times the integral from negative 1 to 1 of e to the negative 2x squared dx. And that's calculator time. And in all reality, if I'm doing this on a test and it's calculator, I'm not going past here, right? I'm not going to bother trying to simplify the thing where I can make an algebra mistake. I'm just going to put it in complicated in my calculator, let the calculator deal with it. You know what I'm saying? Like, don't give yourself an opportunity to do something silly. Let the calculator, who's incapable of doing something silly, handle the algebra. Just make sure you type it in the right way. Chanel, are you happy with what we did there?
Is that all there is?
Well, it says like type in your calculator from here.
Okay.
Right. Part B says then we did the setup.
Okay.
Now put it in your calculator and press enter to get the decimal.
Okay.
And do I have to do it in the calculator? Are you good?
I'm good.
Okay. Nolan.
Do 6.2 number 1. I felt like I knew how to do it the whole time, but I didn't get the right answer. So I don't know.
Okay.
Anything happened to the
Okay. Sure. 6.2 number 1. So I put a whole bunch of them in here, but all right. It says find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. Sketch the region, the solid, the typical disc or washer. Okay. I'm probably just going to sketch the picture and then find the volume and not skip some of the other stuff. Is that okay with you, Knowles? Yeah. All right. So we have y equals 0, x equals 1, x equals 2, and the line 2 minus 1/2 x. So that's like a something like that, right?
Yeah.
So let's actually find out the points. When I do like y of 1, I get 3.5. When I do y of 2, I get 1. So that's like well, it's not used. Let's use I have markers for a reason, right? There's my shaded region. And we're rotating about the x-axis. So am I going to get a convex, concave, or hole? It's going to be convex, right? What's this thing going to look like? It's going to look like a cone with the tip cut off, right? No indents, no hole, solid all the way through, right? So this one is a washer problem. Yep. That's my R. What's R going to be?
2 minus 1/2 x.
Yeah, it's the y, so 2 minus 1/2 x. And so we're just going to be integrating from 1 to 2 and 2 minus 1/2 x squared dx. Does that feel okay?
Yeah, that's what I had.
Oh, so maybe let's do the integration then here. We'll do it by hand. Make sure we get it. Before I integrate anything, I'm going to FOIL this bad boy out. When I do that, I get this, I think.
Oh, that might be where I went wrong.
And then when we integrate evaluating from 1 to 2, so those guys cancel out. This is going to be just kind of annoying, so I'm going to have 4 times 2, that's 8, minus 2 squared, that's 4, and then 2 to the third is cancel, it's going to be plus 2/3, and then minus 4 times 1 is 1, minus a negative 1, and then minus 1/12. And I have some fractions to deal with or whatever, but like, no! Well, that would do it, wouldn't it? Remember our shortcut. Is that?
That's what I did. I got 4 minus 2x.
Yeah, 2 times 2 times a half is 2. Oh, boogers. But that's how I'm doing it quick in my head, is just using that formula. You feel okay?
Yeah.
We sorted it out?
Yeah.
We're good to go? We're good enough? Pierce.
You do 13 from
6, 3. Ooh, scary.
I thought I started up right. I got like really close to the answer, but I couldn't. So.
Okay, well, let's take a look. It says use the method of, oh boy, I pressed the, swiped across the top of my mouse. Use the shells to do this, blah, 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 blah. All right, so let's start by drawing ourselves a picture. When I look at that function, x equals 1 plus yada, 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 what am I looking at there? Excellent. How did you know it's a parabola?
Well, I made like a y-x chart.
When I see a variable squared and then the other variable to the first, I know it's going to be a parabola, right? Now, which way is this parabola going to be going, up and down or left and right? Left and right. Is it going to be opening to the left or opening to the right? Right. So I know it's opening left or right because it's the y that's squared. And because the y squared is positive, it's going to be opening to the right. So if I pick, say, y to be 1, then x has to be 4, right? So 1, 2, 3, 4. And if I pick y to be 0, with what?
You said y was 1?
Mm-hmm. Well, I'm just, oh, sorry. Yeah, I'm looking at the wrong one. Goodness gracious. I should be, yeah, okay. If y is 2, x should be 1. So x1, y2. Great. And if y is, say, 3, x should be 2, right? And if y is 1, x should also be 2. And let's go up to 2, I suppose. If I go to 2, if y is, so, yeah, if y is 4, then x should be 3, right? What's going on? What's wrong with it?
Oh, no, never mind.
I'm not, it's okay, isn't it?
Forgot it was in.
Yeah, it's yx instead of xy, yeah. Okay, so if y is 4, then x should be 5, right? Okay, so that's 2, 3, 4, 5, up 1, and then down 1, and that's probably enough to get ourselves a decent enough picture to figure this out. And then we're got the line x equals 2. Oh, we already had that. I don't know why I bothered with another point. So there's that. And we're rotating about this thing, right? Everybody feel okay?
Yeah.
All right, so we had the point 2, 1 here and the point 2, 3 up there, correct?
Oh, wait, so that, like, supposed to do that.
Well, it said, oh, about the x-axis. Excuse me, I'm sorry. I didn't read the problem. So that's still x equals 2. That's our boundary, but we're rotating about the x-axis. My apologies. All right, so what's this thing going to look like? Concave, convex, or hole? Hole, very good. How can you tell there's a hole? Yeah, there's a space between the function, the x-axis, the axis of rotation in this case. Is that okay? All right. So let's see. So from our axis of rotation, going to have like that as our radius, and then like that would be our height, right? Is that okay? Okay. So what is the radius? It's the y. Everybody agree? Okay. And what is our height going to be then? Very good. 2 minus x, right? We know this is 2, and we know that's x. So the height should be 2 minus x. But we don't want it in terms of x. We want it in terms of y. But that's easy because we know that that's true, right? Or we can just get 1 minus that stuff. Pierce, we doing okay? Okay. So our volume then is going to be the integral from 1 to 3, because we're integrating with respect to y, 2 pi y times 1 minus y minus, quantity y minus 2 squared dy. The 2 minus? Yeah. Is that okay though, folks? Do we see what I did there? Again, when you're drawing the height, you're always drawing back through the shaded piece, right? Chanel?
Sorry. Number 5.
From which section? Oh, sure. Again, if you guys catch any of these that I'm doing are wrong, I haven't been checking in the back of the book. Maybe I should be. If any of these you catch that I did are wrong, I'll give you like a point of extra credit somewhere for it. But you got to be the first one to catch it, and it's got to actually be wrong. Oh, yeah.
Where did the 2 go after you said that x was like the height was 2 minus and then everything is x? Oh, you just
So I distributed the negative through, so I have 2 minus 1 minus, and 2 minus 1 is 1.
Oh.
Yeah. Yeah, I just cleaned it up a little bit so it wasn't so annoying. If it was going in my calculator, would I bother to do the cleanup? Maybe not, right? but I think they probably expect you to integrate that by hand, but I just stopped after the setup so that we can get more questions in. So you're not watching me do like stupid algebra for a whole long time. Now, if you wanted me to do it, I can do it, but let me know. Otherwise, I'm just going to kind of do setups. You guys happy?
Yeah.
Okay. If you need me to go to all the way, though, I can certainly do that.
Well, most of these tests, we were just looking through the setup and we do our calculator, or are you just thinking that we've already done a lot?
It just kind of depends on what the setup is like, or for what the test format's going to be like.
Okay.
You know, if it's like 4 or 5 questions, then yeah, I would expect like setup and integration. If it's going to be a lot of questions, well, obviously you can't set up and integrate like a whole bunch of things because you just don't have the time to do it. So it's a matter of me like deciding how much time do I want you to spend. And maybe I'd rather see you do integration on problems that are specifically integration focused and do setups for these problems that are more setup driven is probably where I would land. So you'd have problems where it's like an integral problem, like you have to do integral. And then there'll be problems where it's like mostly just I need you to do the setup. And maybe a couple or 1 or 2 that are like set up easy integral where it's not like super duper annoying. But I wouldn't have a lot of, it's not like it's going to be 10 of these volume problems, right? Like you just don't have enough time to do that. Because I recognize that although it takes me like a couple minutes maybe per problem, it takes you like 3, 4, 5 times that. Because you're just doing them for the first time instead of like the 15th time. Makes a big difference. I'm sorry, Chanel, I forgot what number we were talking about.
Number 5.
5. That's okay. Okay. This looks like the same problem. No, but it's like almost the same thing. Look at the function. It's that same e to the negative x squared, your best friend. All right, so we have x equals 0, y equals 0, and then x equals 1. And if I'm just going to kind of do some points. So if I plug 0 in, I get 1. So like 0, 1 is here. And then if I plug 1 in, I get e to the negative 1, which is like 1/3. So that's like something like that. And it's probably bendy like this. Doesn't really matter. And then we're rotating about the y-axis. So let's give me a different color. Boop. And it says we want to use shells to do this. Now, in general, would I do shells to do this?
No.
No. Why not?
Easier.
It's convex, right? I just shell it. Give me them shells. Or I'm sorry, give me those discs. Disc, disc, disc. Disc is no hole. Washer is hole. It's a circle with a hole in it. Disc is just a circle.
Washer is like outer radius, inner radius.
Mm-hmm. Yeah, it's pi r outer squared minus pi r inner squared. What's up?
Like a washer.
Like a washer, like you'd use on a tool, right? Like screws and washers and nuts and stuff. Right.
And this one would not be a washer? There's no hole?
Correct. Yes. Now, if we look at this, what's this thing going to look like in 3 dimension? Kind of like the point of a crayon, probably. You guys buy that?
Like a shrinking hole.
Like a tip of a pencil, maybe. Right? All right. All right. So let's see. So maybe we do this. Oh boy. Sometimes this like wants to outsmart me. And it's like, no, I don't want you to do that. So there's like, maybe that's my radius and that's my height. Everybody's okay there? Yeah or no? Could you go the other way? Sure. Because it's convex, you'll be able to do that. If it's concave, maybe not so much.
What do you mean the other way?
Well, like integrate with respect to x instead of with respect to y.
How could you tell what to do when?
Typically, I always draw my radius from the axis of rotation. But I think this one would work out okay because it's convex. But that's typically what I'd want to do, is my radius is perpendicular to the axis of rotation. So I'd be like integrating along that line. Oh no, I'd be integrating with respect to x here. I'm so dumb, because the radius is what we're integrating with. Sorry. Anyways, r is x, right? H is y, or e to the negative x squared. And so our volume should just be the integral from 0 to 1, 2 pi r h dx. That ought to do it. That's supposed to be a dx, and just doesn't look very xy.
Is it dx you're like x wise?
Because we got x's. What I think about when I'm deciding if it's dx or dy is I'm looking at the radius. The radius is going from length 0 to length 1, right? Those are going to cover all my cylinders. Does that do it or no? Does that feel okay, Chanel? You're all right? Yeah, that ought to do. Who's next? Braids?
We do number 5.
6-2, number 5?
Yeah, I'm just going to figure out the columns.
Yeah, sure. Sure. Yes,
They go to that one.
of course.
So we could keep
Talika, I'll give you an A on the next test if you just smash that egg in the minute she leaves the room.
Honestly, I might. Please.
Just leave a big yolky puddle right on her desk.
No, I would never do that, Chanel. Don't worry. Just close to me.
I do. Oh, it's not well.
It's all me. Oh my God.
If she'd asked Pierce to do it, I don't think I would have given that offer. All right.
That's such a bad way.
Braden, what number was this again? 5. Okay, thank you. All right, so I'm going to start by sketching myself a little picture. So what do we got? We got x equals 0. Y equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we got this thing. So I'm just going to pick some values of y and find the corresponding x's. So when y is 0, x is 0. When y is 1, x is 2. When y is 4, x is 4. When y is 9, x is 6. So 1, 2, 3, 4, 5, 6. So it's doing like that. And our shaded region is there. Nolan, what's up? Oh, get your stretch on. And we are rotating about the y-axis, it says. Does that feel okay? And this was a 6-2 problem. So if I look at this, this is convex or concave? Convex. There's no indent, there's no hole. This is disk all the way, my man. So again, I'm going to draw my radius like perpendicular to the axis of rotation. So like that's my R. The R there is just X, which in this case is 2 square root Y. So our volume should be pi integrating from 0 to 9 R squared dy. Yeah, if we're integrating with respect to y, think about the y-axis of the shaded region. So you're just like starting at 0 and going up to 9.
We also do 17.
17. 17 was really hard. Okay, let's take a look. The beautiful part about these is once you kind of get good at it, they're all kind of the same, which is just feels really good. When you're just like, I'm just gonna I can just like knock these out. It doesn't even really matter what it looks like. But being able to get a picture out of it helps, right? Like being able to draw a good picture certainly helps. All right, let's see here. 17. All right. So y equals x squared. What's that? Which way is it open? X equals y squared, excuse me. Opens to the right, correct? So I have like 0, 0, 1, 1, and then 1, negative 1. Oops. And then like 4, 2, so that's 1, 2, 3. And then 2s. 1, 2. Okay. I'm going by halves, FYI, when I'm plotting this thing. Anyways, that should probably be enough. So that's that one. What's this one going to be? Another parabola, right? Which way does it open? Opens left. Where does it start at? Where's its apex? Y should be 1, and then x should be 0, right? Oh, thank you. Ava, it's for you. Oh, if y is 0 is the one that I want, and then x is 1, sorry. I'm so dumb. And then if y is 1 or negative 1, x should be 0, right? So we have like that. And we're talking about this little region in here. And then we're rotating it about the line x equals 3. So that was 2. So there's x equals 3. Sound good? All right. Convex, concave, or hole? Hole, very good. And again, we can tell because there's a gap between the shaded region and the axis of rotation, right? All right. So since there's a hole, what are we going to be using? Washer. Good. So we have like our inner and then our outer, right? So our inner is going to be equal to 3 minus the green x.
Why is it 3 minus the green? Because it's going to the.
Because it's on the green function. Look at where Ri goes to, right? Feel okay? And then our outer is going to be 3 minus the red x. Okay? And we're integrating along the y-axis. So our volume should be pi, and then our outer minus our inner dy. What don't we have, though? The bounds of integration, right? So I need to know, like, that, what those points are, right? To figure that out, I'm just going to set those two equations equal to each other. And since I'm looking for really just the y coordinates, when I set them equal to each other, I want to be solving for y. So they're already set up in a nice way for me to do that. So I'll add y squared to both sides, divide by 2, and then square root both sides. And I'm going to rationalize the denominators along the way. So I have that.
Oh, you have to.
I rationalized the denominator. If you didn't, it wouldn't matter, though.
So it's just the place where they intersect. That's where the bounds are.
Well, again, think about you're integrating along this axis, right?
Yeah.
Because that's our axis of rotation. Our first radius would be here, which is that y value. And our last radius would be there, which is like that y value. So yes, it's just the intersections.
Okay. Is it always the intersection? Like, if there's two curves, like, it would be that, or?
No. I mean, you could have something like, so let's say we have this x, and we have like that does this, and this does that. There, the intersect, where the curves intersect doesn't matter, right? Because our shaded region just starts and stops at those x's, so like the intersections don't matter. So it really kind of depends on the picture.
Okay, I got it.
Does that, you
That
can
makes
see
sense.
why, yeah. So like it's not hard to come up with something where the intersections don't matter, even though you have two functions, one on top of the other. Just depends on if they intersect to make the shaded region or they don't, right? Or it'd be easy to have like one intersection matters and the other doesn't,
Okay.
right? Like I could do that. It wouldn't be hard to come up with a situation where that, but like you're getting kind of in the weeds here. But in general, the picture tells you, is what I would tell you. Like, get a decent picture, and the picture should make it real clear, like, what are my bounds of integration by looking at it? It's like, where does this thing, I'm drawing slices like this, where's my first slice at? It's at the bottom. Well, that's the intersection. And I keep slicing this way. What's the last y value that I slice at? Well, it's the top. That's where they intersect again. Like, okay, we can do that. Braden, does that feel okay. And again, I didn't solve anything. We just kind of did the setup and
Yeah, I just struggled with finding the values and then finding out like the 3 minus x part.
yeah, it takes time to get comfortable looking at the picture and like seeing it in 3 dimensions. But it's one of those, like, once you get it, it's like, okay. And being able to see the thing in 3 dimensions helps, right? Like, I don't see in detail what the thing looks like, but I'm like, okay, it has a hole in it. This is the inside, that's the outside. Like, washer will do, easy to write it, and just like, boom, 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 go, go, go. Because most of the time you see all I draw is this picture, right? I stopped drawing the 3-dimensional shape because it doesn't really help me write the equation after, other than getting, like, figuring out kind of what it's going to look like. Is it convex, concave, or got a hole through it? That's really all I care about. What do you guys think? Do some more? Chanel, you said you had a whole bunch.
Can you do 33 from 6.2?
6.2, number 33? Sure. I think we have those problems up here somewhere, right? Yeah. I'm not going to copy and paste them in again. I'm just going to, like, do like one of, hey, come on now. Do one of these. All right. So x squared plus 4y squared equals 4, and we're rotating about the line y equals 2. What kind of shape is x squared plus 4y squared equals 4 got to be?
Circle?
It's not going to quite be a circle. He's just being a creep. It's okay. It's not quite a circle. No. It's an ellipse. An ellipsis is the dot, dot, dot at the end of a sentence. An ellipse is the shape, but I knew what you meant. Easy way to tell. So let's find some points. So let's say y is 0. What has x got to be then? Or -2. Okay. Now let's do the opposite. Let's make x 0. What's y got to be? 1 or? Okay. So if I do that, let's see. 1, 2, 3. I'm going to go by halves again. 1, 2, 3. There's my ellipse, right? Does that feel okay, Chanel? Okay. And then we are rotating about the line y equals 2. So that's here.
It's like a convex. No, but there's a hole in it. So
It has a hole. So we are doing washers. As soon as you get a hole or convex, it's washer time more often than not. Maybe you have to do a shell if it's the wrong kind of convex, but yeah.
So how do you?
I'm sorry, not convex, concave. Concave or hole is washer time.
Okay. Wait.
Or maybe shell. Probably not, though.
How can you like tell the difference between convex, like I know how a hole looks like, but what's convex and concave? I'm sorry, like
So, like,
it's been so long since geometry.
if you have, like, a bowl,
Yeah.
that's concave. There's a hole in it. There's like an indent in it.
Okay.
If it's just like a half a sphere, that's convex. There's no hole in it. There's no indent.
So like, what do you mean by an indent? Like in the
Like a cave in the surface.
Okay.
right? Like,
Like a moon? Like a moon shape? Like a crescent moon?
well, you have to think about it. It's three-dimensional, though.
Okay.
What's a three-dimensional crescent? I'm not sure.
A smile? Like,
Usually it's like you have, you know, like say you have a vase, but it like goes down like this, like there's a hole,
like a
like
Hershey's kiss?
missing out of the inside of it, like that's
Oh,
concave,
okay.
right? But if it's just like a Hershey's kiss, that's convex.
Okay. So like for example, let's say the Hershey's kiss had like a, you know, like a, I don't know, a divot or something in it, then that's
Concave.
Okay.
Yeah, concave is indent, right? Has like a chunk missing out of it.
Okay. Got it. Thank you.
Yeah. Okay.
Wait.
Yes.
So for washer, it's the radius of the outer minus the radius of the inner.
Correct.
You take the ellipse problem and split it into x, y.
We're going to be doing that. Yes, that's kind of the idea. Yep. So let's draw our picture. There's my R inner, and that would be like my R outer, right? Okay. So R inner should be 2 minus y. Everybody agree with that? R outer should be
Is it 2 minus 5 y?
well, if we think about this guy was the function x squared plus 4y squared equals 4. If I want to write this in terms of y, I would subtract the x squared from both sides, divide both sides by 4, and then square root both sides, right? When I square root both sides of the equation, I get the plus or minus. So what this is saying is that this top part is y equals 4 minus x squared over 4, and the bottom part is y equals negative 4x squared over 4. Right?
Oh, so you're just,
So because I want to make sure the radius is a positive number, this y value is 0 or less than 0. So to make sure that's positive, I need to minus the negative. Right? If I'm looking at the distance from 4 to 7, well, you just do 7 minus 4, right? If you look for the distance between negative 4 and 7, you do 7 minus negative 4, right? So that's same kind of idea here. Does that feel okay?
yes.
So our volume should be pi, and then we're integrating from negative 2 to 2. And then we have 2 minus, 2 plus 4 minus x squared over 4 squared minus 2 minus square root 4 minus x squared over 4 squared dx. And I think that'd do it. Now, I think this was a 6-3 problem, yes?
Yeah, 6-2.
Oh, is it 6-2? Okay. Then yeah, they probably wanted you to do it this way. You could have done this one with shells also.
Why is it minus 2 to 2, by the way? Like,
So we're integrating along the x-axis here, right?
yeah. So this is,
So we're starting at this x,
Okay.
right? When we're drawing taking our cuts, and we're ending at that x.
Okay. And then you got, so, why, oh, you put it in terms of y, right? And then you're spinning on which axis again? You're spinning on the
Horizontal, y equals 2.
horizontal. So it's in terms of x.
Mhm. Yeah.
So when you're spinning it in terms of x-axis, it's x, y-axis, it's y.
So I always think about, I'm going to slice perpendicular to the axis of rotation. because my radius is always going to be from the axis of rotation back to the solid. So that's the way I think about it. So if I'm spinning around a horizontal, I'm going to be slicing from left to right. I'm going to be slicing along the x. If I spin around the vertical axis, well, I'm going to be slicing this way now. So I'm going to be slicing y values. Does that feel okay?
Yes.
And I think that's the better way to kind of conceptualize it.
Yeah, it was getting kind of confusing. I'm like,
Because that, to me, I can work out in my head if I get stuck. If I try to memorize this, like, hey, this goes to this, I don't like doing that, because if I screw it up, then I just screw it up the whole time. If it's conceptual, I can at least like think my way through it if I question what I should be doing. Does that feel okay?
yes.
That, again, just doesn't matter whether I'm doing washer or disc or shell, the radius I'm drawing is always from is perpendicular to the axis of rotation, you know? That was a fun one though, huh? This trick right here, super non-trivial. Like that was hard. Coming up with that idea that you're like, oh, that's how I'm going to have to differentiate between the top half of the function, the bottom half of the function. Mm-hmm. You know, that this was positive y, and then this one is like the negative y. That's sneaky stuff right there. That's not trivial, and not like super duper obvious that that's what you'd want to do, right? It's a tricky bugger right there. I don't think I'd give you something that tricky to sift through. You ready to hear some good news?
Yeah.
So we've talked about these three methods, right? Disc, washer, shell. On the AP exam, they're not going to give you anything that needs to be done as a shell. They will all be things that you should be able to easily do as a disc or a washer. Here's your bad news. Your first or second year calculus professor, depending on how your course is structured, will for sure expect you to do things with shells that can't be done easily with washers or discs. Just to give you a heads up. That's why we're spending the time to do it, because someone in the not too distant future, more likely than not, is going to expect that you're able to do this. But it's not going to be on the AP. This won't be the last time we do something that like somebody in the not too distant future is going to expect you to be able to do, but it won't be on the AP exam. But that's the gist of it. Is that okay? So again, like if you really got to be able to do something, it's disc and washer, right? Got to be able to do that stuff. Will the AP care if you do a shell to do an integral, one of these volume problems?
No.
No, man, they won't care. So you can do that still if you like. And most of the problems that can be done with discs and washers aren't really any much harder to do as a shell problem. Pierce, is that a stretch or a question? It's okay. You guys got more questions? Somebody asked about 44 from section 6.3. Did anybody try that one? That was a fun one. Was it on the list? I think it was on the list, wasn't it? You think so? Let's try doing that. Oh, what is happening outside?
That's crazy.
What?
It's snowing, dude.
Snow day.
Yo.
Yeah. Let's get my other test canceled.
That was cool.
What does she have tomorrow?
I just like on Thursday. Oh, that's not what it is.
You guys were all complaining about how bad this week was going to be for tests.
She moved bio.
Oh, that's the one that just like if there's a bio test that week, it's just like
It's so
life is over.
Yeah, it's so the material is so bad. Like it's really hard.
Yeah, it's really have a 28% chance.
I would make sure I have my alarm set.
Thursday, so
It's a limited chance. Maybe Friday?
No, Thursday.
So maybe Friday. Maybe I won't even have to. No,
it's like physics is 10 a.m. when then test is 7.
Well, I
So basically
just, I
something.
figured out halfway through how I calculated the loss energy.
Oh, I did the same thing in the morning.
Yeah. And then Joe's like, oh, it's not super. You know, all the questions you did. I was like,
Yeah, exactly. Sure, this is a jail thing. Conservation. Oh, that's
All right, what we got here?
Hey, guys, it's National
No,
Pancake Day. You can get
no,
free
it's not
pancakes.
That's like a punishment, though.
Why?
I have pancakes aren't any good.
What did you say?
It's like punishment.
You don't like pancakes?
Not from IHOP. They're pretty bad.
Well, you can get them from Jagged Fork.
Okay.
Oh, Dragon Fork.
I know myself.
All right. Let's take a look here at 44. Right. This is in the set, I think. So we have a triangular region with vertices 0, 0, 1, 0, and 1, 2. Right. So that's what I've drawn there. And we have a axis of rotation at x equals a. And they want us to find a in terms of the volume of rotation. Pierce laughed. It's pretty easy, I know. Well, what's this shape going to look like? Hole, convex, concave.
You're gonna have a hole.
Hole. Right? Because there's a gap between the solid and the axis of rotation. So R inner, R outer. You could also do this with shells, but let's just do it this way. It's not bad. Everybody's okay? So R inner is going to be excellent. Everybody agree? Our outer is going to be, nope. We need an equation for that line.
Oh.
Right? That our outer is not going to be constant. It's going to change. Okay, what is the slope of it? Right, just y equals 2x. Goes through 0, 0. What's the y-intercept got to be? 0. Then it goes to the point 1, 2. What's the slope got to be? 2. I'm done, right? So this is going to be 2 minus x, but x is really, yep. Everybody feel okay there? So our volume should be the integral from, Braden, give me the bounds. Well, we're doing slices this way, right? Yes. 0 to 2. And then we have our outer minus our inner. Okay. So let's go ahead and do our integration. I'm going to FOIL this piece out, but I'm not going to bother foiling the other piece out. Why don't I need to FOIL out the other piece? Nope. Why don't I need to FOIL out the other piece to do the antiderivative of it? No. Maybe if I write out the antiderivative, it'll make sense to you. Why is the a minus 1 squared times y the antiderivative? What? Right, so it's just a constant. A minus 1 squared is a constant. Right? Y is the variable. A is a constant. A minus 1 squared is a constant. I don't need to FOIL it out. You could if you wanted to. But like...
It's supposed to be dy next.
Yes. Everybody's okay? So let's see what we got here. Oops. I'll just divide that pi over. Get that out of there. So I'm going to have a squared times 2 minus a times 2 squared over 2 plus 1/4 2 cubed over 3 minus a minus 1 squared times 2. And then I have minus zeros after that, right? Because everything's got a y in it. So I have 2a squared minus 2a plus 2/3 and then I have minus, well, I guess we got to FOIL this out now eventually, right? 2a squared plus 4a and then minus 2. So let's see here. And then that's going to give me a 2a and then minus 4/3. So I'll add the 4/3 over and then multiply by a half. Looks right. Or v over 2 pi plus 2/3. What'd you think? Nasty, right? But like if you got it, like you do that, where it's symbolic instead of numeric, like you can do whatever here. I think in the textbook, when I looked this up earlier, when the first hour asked about it, the textbook used shells to do this instead of washers. That would have been fine too. This one I looked at, it just said washer to me. The algebra for the shell was probably easier, but, you know. To me, it's whatever. Maybe the derivative was easier because you didn't have to FOIL anything out. I don't know. Or maybe it wouldn't have made really much difference. I didn't look too hard at the details. I just looked at, oh, they did shells. Oh, we got the same answer. Who cares? How do you guys feel? Any better today than you were?
Yeah.
Yes.
Yeah? All right, well, I have some presents for you guys.
What's this?
I need to hand out all my gifts first. No. It's all yours. It's all yours.
Well, it's just me?
Yeah. I think. Oh. It's your birthday?
No, but looks like I'm getting presents anyway.
This is a Valentine's Day present because of how much I love you guys. Yeah, you know, it'll be a good time. Yeah, if you want a staple. I just didn't get a chance to do any staples. All right. So, you guys should, for next class, try to do these. We're going to randomly call on individuals to do their work on the board, show us what they got.
Nice.
Not to embarrass anyone, but simply to try to get you some more individualized feedback. Show me, write down how you tried to do it. We can talk about what's right or wrong or good or bad or whatever with it. And get you some individualized feedback. I know that this is hard, what I'm asking you to do right now. You just got to stick with it. You got to practice. You got to keep trying. And it will get easier. It is like everything is kind of the same once you get there. I know it doesn't feel kind of the same right now, but all of these problems are kind of the same. You just have to like see enough of them to see like, oh yeah, still, yep, radius, whatever, like that's good enough. Like, yep, this function minus that thing, yep, okay. From here to here, okay, good. But right now it's like, ooh, which am I integrating with respect to x or y? Oh, what are the bounds of integration? Oh, what's the radius for this thing or that thing? Or is it a washer? Is it a shell? Is it a disk? Those are all questions you're having. Once you get that stuff sorted to be quick, you're going to see that like, oh, these problems are all the same. That they're all cross-sectional area times height. And by height, I mean dx. But it takes some time to get there, right? So keep on with stuff. Next time we're going to do some more U-sub techniques. So specifically, we're going to look at U-subs with like a rational function. And what can we do with that? Like if you have polynomial divided by polynomial and we want to integrate this, how the heck do I do that? Because I don't have an antiderivative formula here. We're going to show you the different techniques we can use to do that. And then that'll be next time. There's like 3 or 4 different techniques that you might consider using depending on what the thing looks like. And that'll be it for this week. I'll give you guys, before break, I'll put up the multiple choice and the free response practice problems. We'll probably have another lesson or 2 when we get back, but it'll be test time pretty quick. Just giving you a heads up that that's coming again. And then after this one,
One more test.
I think, well, there's just one more after this one, yeah.
one question. The anti-integral, the dy just being a y.
So the dy is part of your integral symbol.
Yeah.
So I don't even think about it as anything. It's just like what I like.
Where did this y come from?
This is the start. You're integrating a constant, right?
Oh,
The
so
integral
then
of
that
2
pops
is
up.
just 2x or whatever, 2y.
Oh, I was so confused on that one. Okay.
Yeah.
That makes a lot more
A minus 1 squared is a constant, so just like
Yeah.
like a 7 or something. So it becomes 7y.
Thank you.
Mr. Gould, me and Ava both got emails to go talk to Miss Lawrence, so can we just...
Yes, of course.
Thank you.
Pierce.
I'm having like a brain fart right now.